Hi guys, this is Mrs. Allison. Hopefully you did not or have not watched this video until you've tried those 6 problems above. So I'm going to ask, if you haven't tried the 6 problems, hit pause and go back and try the problems and then come back. So the 2 problems that I imagine most of us got right away were number 2 and number 5. So let's look at number 2 and number 5. Okay, number 2, I have a total of 32 on the right-hand side, and then I have 4 boxes on the left-hand side. So I would assume most of us for our boxes got 8 in each of our box. Okay, is there any other answer that when I multiply by 4 gives me 32? I can't think of any. So let's look at number 5. Looking at number 5, we've got the same idea where I need 3 boxes to add together to give me 30. So probably most of us got 10. Were there any other answers that go with this? I can't think of any either. Okay, so let's go to number 1 next. This one says that 1 box needs to equal 1 box. So what did you get? Okay. Did any of you get 5? Is that correct? Sure, that's correct. Did any of you get -3? Is that correct? Yeah, that's correct. Did any of you get 7 for your boxes? Is that correct? Yeah, these are all correct possibilities. Is it okay that that happens? Is it okay that everybody got a different answer? Okay, what about number 4? Well, did anybody get 2? Does that work? Are both sides balanced? Right. What about 1? Did anybody get 1? Are both sides balanced? Sure. Did anybody get 72? Are both sides balanced? Yeah, is that okay? If they're balanced, they're balanced, and that works. So all of these are possible answers. There could be a million more answers as long as what's in the box are consistent. Okay, well, let's talk about number 3. Okay, so if I were to eliminate the 20 and the 13, right, I were to hide those 2 numbers, wouldn't this problem look just like number 1? Sure. Okay, so if I hid 20 and I hid 13, meaning I were to cover them up somehow, if I have a balanced scale, so let's say I put the number 5 and 5. Do you agree that if I don't have the 20 and the 13, we can't see these numbers, that scale is balanced? Yeah. But what happens if I put a 20 on one side? Is it balanced anymore? No. And what if I put a 13 on the other side? Is it balanced anymore? No. So what do we know about this? Are there any answers that we can use on here that give us a balanced equation? I can't think of any. So let's look at number 6. And the same idea as number 3. Let's hide the 20. Pretend it's not there for right now. And all I have are the 2 boxes. What numbers could go in there and make it balanced? Right? It could be anything. It could be 42. It could be -13. So let's just pick something silly. Let's pick 42. And if I go and decide to put back in the 20, put it back on so you can see it now. Is the scale balanced anymore? Nope. It was balanced, but now it's not balanced. So is there any number that I can put in there and have it work? No, there's nothing. So these are no solutions. So, okay, there is no possible answer. And it means I lied to you just a little bit because I did tell you that the scales were balanced. But sometimes we have equations that have, in fact, no solution. So this would be an example of an equation that has no solution. It cannot be balanced. There's no way to solve and make both sides work. That's okay to have. It's okay when we get something that never will be true for it to be called no solution. In that same idea, though, we have one other type of solution, and that is what we call an infinite number of solutions. Or we could say all real solutions. And all real solutions is where it doesn't matter what number I pick, we are going to have an answer that works. Doesn't matter if it's negative 72, 46, 31, 5,280. It doesn't matter what the number is. A solution will always be found for ones that have all real solutions.